Welcome, everyone. I am so glad you're here with us today. You're stepping into an incredibly important role. As new fire alarm technicians, you're about to embark on a career that is vastly different from most. A lot of jobs involve working with equipment, right? But very few directly involve safeguarding human lives. And honestly, because buildings today are heavily constructed and packed with modern synthetic materials, fires burn significantly faster than they did just a few decades ago. That makes your job more critical than ever. So before we even touch a control panel or strip a single wire, we need to establish the foundation of what it is we actually do. My goal today in this explainer is to act as your mentor, to walk you through the immense, profound responsibility you're taking on. Let's get started.
Okay, I want you to really picture this scenario. It's 2 a.m. in a massive residential building. Most of the occupants are sound asleep, right? But deep down in the building, in some forgotten storage room, a fire begins. It starts producing toxic smoke long before any actual flames become visible. Now, without a fire alarm system, those sleeping folks might not even realize a fire exists until their escape routes, like the hallways and the stairwells, are totally choked with smoke. And by that point, evacuation isn't just difficult, it becomes literally impossible. This right here is the life or death reality of the job you're stepping into. The systems you'll be installing are the only thing standing between those people and an absolute tragedy.
To get you ready for the field, we've put together this life safety roadmap. We're going to breeze through buying time for survival, the anatomy of a fire, active versus passive protection, navigating codes in the AHJ, and finally, habits that save lives.
All right, let's dive right into our first section, buying time for survival.
I want you to let this next thought really sink in. Fire alarm systems are not installed because a code requires them. They are installed because people need time to survive. Every single device you install, every smoke detector, pulse station, horn, strobe, control panel, the whole shebang, serves this one overriding purpose. We are literally in the business of buying people time. During an emergency, time is absolutely the most valuable resource a human being can possibly have.
So how do we actually buy that precious time? A properly designed fire alarm system provides three core functions. First up, early detection. Smoke and heat detectors are continuously monitoring the building. The second signs of fire appear, the system reacts instantly. Every single second matters here. Second is notification, because let's face it, detection is totally useless if nobody knows about it. Horns, strobes, and voice evacuation systems get people moving before conditions turn lethal. And finally, emergency response. Modern systems communicate directly with monitoring centers. This drastically cuts down response times, allowing firefighters to arrive way sooner, which maximizes the chance of preventing injuries and fatalities.
Moving right along to the next part, anatomy of a fire. You know what's truly fascinating about combustion? It's the sheer simplicity of it. It's basically just the chemical process that happens when heat, fuel, and oxygen combine. It's not magic, it's just a highly predictable chemical reaction. Now, as a technician, understanding this is absolutely vital. Why? Because if you remove just one of those three elements, the fire completely stops in its tracks.
The classic fire triangle brilliantly illustrates this whole concept. We've got heat, which is your ignition source, think an electrical failure or a random spark. Then we have fuel, which is anything that can burn, like wood, paper, or plastic. And of course, oxygen, drawn right from the surrounding air. When these three buddies get together, boom, you get combustion. Our early detection systems are the very first line of defense to prevent this triangle from completing. If a detector is installed too far from a potential fuel source, maybe because of a tricky ceiling layout or some weird obstacle you found in the field, that primary defense fails and the triangle gets completely out of control.
Fire actually develops in 4 predictable stages, and understanding them shows exactly why early detection is a literal race against the clock. First is the incipient stage. The fire has just started, there's barely any heat, but smoke particles are being produced. This right here is our golden window. It's the absolute ideal stage for detection. Second is the growth stage. This is where the fire really starts spreading, heat rapidly increases, and smoke accumulates, making conditions incredibly dangerous. Third is the fully developed stage, where the fire reaches maximum intensity, and well, occupant survival becomes highly unlikely. Finally, the decay stage, where fuel starts to run out, but dangerous gases and structural instability stick around. The entire goal of our detection systems? Catch that fire in the incipient stage, buying folks the time they desperately need to evacuate before that deadly growth stage takes over.
All right, that brings us to active versus passive protection. When we talk about fire protection, it's divided into two very distinct categories. Active protection systems respond when a fire actually occurs. This is our world.
Fire alarms, sprinklers, clean agent systems. They actively detect, notify, or suppress. Conversely, passive protection systems don't need to be activated. They are literally always working. We're talking about heavy fire-rated walls, thick fire doors, and smoke barriers built right into the architecture just to slow the spread of fire. As a technician, sure, you work on the active side, but you absolutely must understand how your systems integrate with the passive side to create one giant complete shield for the building's occupants.
Moving on to a huge part of the job, navigating codes and the AHJ. Listen, you can't simply install devices wherever you feel like it. Our industry is heavily regulated, and for a very dark but incredibly important reason. Codes are often written in response to lives lost. I want you to take a moment with that. When you're sweating, struggling to pull a wire in a 100-degree attic, and you are so tempted to just skip a specific wire support requirement, remember that every single standard exists because lessons were learned from real-world tragedies. These regulations are basically paid for in blood. As professionals, we benefit from those hard-learned lessons, and we have to respect them without exception. So, your foundational texts include NFPA 72. This is basically the fire alarm Bible. It dictates exactly how we install, test, and maintain systems. It's your primary playbook for sure. Next up is NFPA 70, the National Electrical Code, which covers all our wiring methods and circuit protection. Then we have the building and fire codes, like the IBC and IFC, and finally, there are the manufacturer documents. Now, a lot of technicians overlook this, but if an installation manual for a complex duct detector conflicts with your standard field practices, the manual almost always wins out. You absolutely have to read the instructions.
And then there's the AHJ, or Authority Having Jurisdiction. This is the organization or individual responsible for actually enforcing those codes. This could be the local fire marshal, a building inspector, or maybe an insurance rep. And they have the absolute final say regarding the acceptance of your installation. Now, during a final walkthrough, please do not view the AHJ as an obstacle or the enemy. A really good technician views the AHJ as a partner in life safety. At the end of the day, you're both working toward the exact same goal: keeping people alive.
Okay, let's wrap this up with our final section, habits that save lives.
The best technicians out there completely separate themselves from mere mechanics by developing rigorous daily habits. First, verify everything. Never just assume a circuit is dead or a detector is programmed right. Test it yourself. Second, document everything. Good paperwork protects the customer, and frankly, it protects you. Third, follow the standards. Apply them consistently in your everyday grind. Fourth, continue learning. Technology and codes are constantly evolving, so you've got to evolve right along with them. And finally, take pride in your work. Taking shortcuts is just never acceptable when human lives are on the line.
This right here is the butterfly effect of our industry. You know, a sloppy connection or an improperly seated resistor might seem incredibly insignificant when you're rushing to finish up a job on a Friday afternoon. But months later, that tiny, seemingly harmless error could prevent a detector from communicating with the panel during an actual fire. That single loose wire could literally be the reason the alarm doesn't sound and the occupants don't get the time they need to escape.
I really want to leave you with this final, provocative thought. As you head out into the field, remember that your work will mostly go completely unnoticed when everything is operating correctly. The occupants of the buildings you protect, they'll probably never know your name. They won't know the incredible care you took to strip that wire perfectly, or the extra time you spent verifying that obscure code requirement. They simply trust that when they go to sleep, the building is safe. They trust that the system will just work. Your personal integrity directly impacts their survival rates. So, will your work today earn their trust? Welcome to the life safety industry, everyone. Now let's get out there and get to work.